guys, welcome to Brainwave Academy. We are still on dimension, physics, one of the topic in physics. So now the question says that was use dimensional analysis to check for the correctness of the following equations. So we are going to use dimensional analysis to check for the correctness of all these physical equations. As you can see, these are the equations of motions, and how can you solve for the correctness of the physical equation? If you get all the dimension for each data here, it is very easy for you. As we know, that this one is what final velocity, this is initial velocity, this is acceleration, this is the time taken, this is final velocity, initial velocity, this is acceleration, this is distance, and also here is the same thing. So what you're going to do is that if you can solve for the left hand side and the right hand side, and they have something in common, therefore we said that the equation is what dimensionally correct. Let's start from number one. We have V is equals to U plus AT, and we know the dimension for velocity V is equals to LT minus 1 in my previous video. Whether it is initial velocity or final velocity is still the same thing. We have U is still the same thing as LT minus 1. And the acceleration A is equals to LT minus 2, while the time T is equals to T raised to power 1. So let me impute it into this equation. What is velocity is LT minus 1 is equals to LT minus 1 plus acceleration is LT minus 2 times T raised to power 1. So we now have LT minus 1 is equals to LT minus 1 plus L is common. LT is, now you add the power because of according to law of indices, we have minus 2 plus 1. We have LT minus 1 is equals to LT minus 1 plus LT minus 1. If you look at it, LT minus 1 is common here, it's also common here. Now, since that they are common, both left and right, you say the equation is dimensionally correct. Since the left hand side and the right hand side of the equations are common, hence the equation is dimensionally correct. Let's check to the second one. The second one, number 2, we have V square is equals to U square plus 2AS. We already know the dimension for velocity. The dimension for velocity is LT minus 1, then all square is equals to LT minus 1 again, all square, plus in dimension, constants are not what? We are not going to include what constant, whether it is pi 22 or 7, 2 is, we have to omit these two because constant value. So we have to have AS. What is A? This one is gone now. A is now LT minus 2 times distance is what? L is L. So according to law of indices, this is the power. You multiply the power together, and this power affects both L and what? T. L is something as L raised to power 1. Here is also L raised to power 1. So L, we have L now. 1 times 2, we have 2. T minus 1 times 2, we have minus 2. I'm done with this. I'll expand that. L now, we have L here again. 1 times 2, we have 2. T minus 1 times 2, we have minus 2. Plus, here is L raised to power, here is L raised to power 1. We have L. 1 plus 1 is 2. T raised to power minus 2. If you look at this from the left hand side and the right hand side, all they are common. They are common. From left hand side and the right hand side, L squared T raised to power minus 2 are common. Hence, the equation is dimensionally correct. I'm done with that. Then the third question, number 3, let me start from here. We have S is equals to UT plus I have AT squared. Something is supposed to be omitted here now, which is still the constant again. We have to omit this. So the equation will change to S equals to UT plus AT squared. We have omitted the constant because we are dealing with dimension, and this is distance. The dimension for distance is L from my previous video. U is L is what? Velocity, which is LT minus 1 times time is t raised to power 1 plus acceleration LT minus 2 times time square, which is t raised to power 2. So we now have L is equal to L. This is t is common. You add the power minus 1 plus 1 plus L. Add the power for the t again, minus 2 plus 2. We have L is equals to L t minus 1 plus 1 is 0 plus L t minus 2 plus 2 is 0. And anything raised to power 0 is 1, which is L is equals to L times 1 plus L times 1. So we have L is equals to L plus what? L. As you can see, L are common here, which means that the equation is also dimensionally correct. Please do well and subscribe to this channel to see many video of this. Please like, share, and comment. Thank you, and peace out.